Hi, Assalamualaikum. So, another student have asked about the assignment on finding or open reading frame of a given sequence. So, here it said find the nucleotide sequence for hemoglobin in the organism Mus musculus. So, what is Mus musculus? It is a house mouse. So, go to NCBI, click on nucleotide, so 1 hemoglobin and musculus. Okay, so there are 346 musculus hemoglobin protein. So hemoglobin, it's a large protein, so we have a lot of protein here. So you can choose any, or just choose the first one. Hemoglobin Y, beta-like embryonic chain. Okay. Right, so this is the gene bank data. Okay, so this is a lot, so we want the nucleotide sequence. So you need to print screen this part for your report. So this is the nucleotide sequence. So the next question, find in which all frames you have ORF, open reading frame. So you need to open or find them, yeah? So from here we can just copy the reference sequence, or if you want you can copy the whole nucleotide sequence, but you don't need to when you have your reference sequence. So you just put here, enter accession number. Okay, so we'll keep the parameters to the default. So we'll just put this ATG only for the start codon. Okay, so we'll have to assume that the start codon code is only ATG. So we have 6 ORF found. Okay, so here you can see that not all frames have ORF. So we have -1 but not +1, not a positive strand, only the negative strand, and +2 but not +2 and -2, +3 but not negative strand 3. Okay, so you can display ORF as the nucleotide sequence if you want to see the nucleotide, otherwise it will put it as a protein sequence. So for this one, find in which all frames you have ORF. So it's not like, the question is quite confusing. I think it's find in which frames you have ORF, because not all frames have the open reading frame, as I said just now. So this is the answer, yeah? Okay, so for this one, if you can print a PDF, horizontal PDF for this page, yeah? So you can put this in your report. Find out which ORF is the longest in length. So you can look at this one, yeah? Find out the longest ORF is in which frame, its length and location. Actually, it's the same thing. The location. Yeah. And then perform a blast search with any selected ORF. So you can, I like this first open reading frame 1 here, from the positive strand of 2, frame 2. So if you remember, if you read the theory, you know that the +2 is where it formed it by leaving the first nucleotide and then grouping the sequence into the words of 3 nucleotides here. So it basically remove the first one and try to read it from the second nucleotide. Yeah, so that's why it's called frame plus 2. Okay, so you can just right click here, blast search. You can also do primer if you want to perform some molecular biology work. Okay. So here it's a BLAST page. So we have nucleotide BLAST, BLAST-N, we have the protein BLAST, search protein database. This one, search protein database using a translated nucleotide. So there are so many tools that you can do to study your gene or your protein. Yeah? Okay, so I'll just keep this into a default organism. Semua tu kita biar. Just want to see what is BLAST search. Okay, when you are doing this for your final year project or your postgraduate, you may want to change the parameters. Okay, so this is a query of your BLAST. So we are actually not going from the nucleotide sequence that is put in here. Okay, so we are predicting the open reading frame. Yeah, so the first open reading frame start from the 56 nucleotide and stop at the 499. Yeah, so why do we want to do BLAST? Because we want to see whether it is a functional gene and whether it's actually start at the 55 nucleotide. Okay, so if it is, then you will have a good BLAST output. So this is what you see. Wow, so there are so many here. Let me see. For the assignment, said perform a BLAST search. Yeah, okay. So this is what you get. So you can just print this here. So you can also read how to read this page. Maybe let's look at the search summary here. That's for the summary. So here it shows different BLAST result for your search data, the ORF1. So one of it is here. So the coverage is 21%, identity 95.9%. There are 6 mismatches with 0 gap. Okay, so this is Mos-Fahari hemoglobin subunit epsilon. Okay, so when you look at this, it actually starts. So the query is from 55 here, but this one actually starts from 1 here. So it means that probably the same as this one. If you run BLAST from the nucleotide, okay, this is for additional information. If you run BLAST here using the original nucleotide, okay, I just want to show the differences. So here we have very similar sequence with the other musculus hemoglobin, etc. Okay, alright. But because we are blasting the predicted ORF here, starting from 56 to 499, then we have a different data from your blast output. Okay, so why the ORF is not finding the same from the nucleotide 1 to nucleotide 619? So probably because we have actually put the start codon as ATG only. If we put it in a different one, ATG and alternative initiation codon, let's see what happened. So we have found 11 ORF, okay. So it's basically give you alternatives of the nucleotide that we have given. So basically it also comes out with the first with ORF here from 56 to 499. So this is the longest nucleotide length. Okay, so if you have sequence a genome and unknown genome, you may have to do this open reading frame prediction, and then you may have this data only. Okay, so probably here this one we have they have looked at it using other biochemical experiment in order to determine that the nucleotide actually start from this part until this part, yeah? A functional gene. Okay, so that's all I think for this one. I hope I'm not confusing you further with the additional information, but I think the first 6 to 7 minutes I have showed you how to answer this exercise. Thank you very much.